Yes, good day, class. Today we are going to be talking about regression analysis. Just like we all know, when we talk about regression, we are trying to look at two or more variables, how they are related, the extent to which they are related, and how the independent variable or independent variables, as the case may be, predict the dependent variable. Usually there is what we call regression model, where we have y equals a plus bx. In that model, our y usually represents dependent variable, while our x represents independent variable. For a simple regression analysis, we only have two variables, one independent and one dependent. Unlike a multiple regression, where we have one dependent variable and two or more independent variables. In that case, for a multiple regression, you are going to be having b1, x1, b2, x2, and so on and so forth. But for this class, we are going to be focusing on simple regression analysis and how to solve it using simple statistics. The simple approach to it. In this example, we are trying to be looking at 4 students, their performance in further mathematics and performance in mathematics. And we are trying to look at how performance in mathematics affects the performance in further mathematics. Take note of that. How mathematics affects performance in further mathematics. That will help you know that mathematics is going to be your independent variable, which is the predictor variable, while further mathematics will then be the dependent variable, which is the outcome variable. Taking note of the fact that y equals to a plus bx regression model or regression equation. Our y is this and our x is this. Then that means that our a and b are unknown. If they are unknown, a is the constant, b is the slope or gradient. For us to now find our a and our b by formula, we only need to solve for summation y minus b summation x over n. That's for a. And for b, n summation xy minus summation x summation y summation y square minus summation y square. More importantly, if you go back to the example that we have here, it then implies that we will need to lose all this from deducing it from what we have here. So that means for us to find our A, we need to first of all find B. We don't have to find A without B. It is impossible just because the value of B will be inputted here to get our A. So it will make sense. So for us to find our B, that means that we need summation x, y. We need what again? Summation x. We need what again? Summation y. And we need what again? Summation y squared. These are what we need for us to find our what? Our B. So let us come back here. When we say we come back here, it implies that if this is our y and this is our x, summation y, summation x will imply that you will find the sum. So let us do that. 50 plus 38, 88 plus 71, 88 plus 71 is
164.
164 plus 66,
230.
230. So that means our summation y is what? 230. Our summation x, 72 plus 49.
121.
121 plus 69.
Everything to 58.
190.
190 plus 68.
258.
So that means our summation x is what? 258.
I think this is why you want. 88 plus 71 is 169. No,
88 plus 71 is
169.
169. 169 plus 66 will then give you what? 169 plus 66 will give you what? 225. Thank you for that observation. 225. You have to be careful when doing all these summation. Now, from the 4 unknowns that we have to get our B, we have been able to get 2 unknowns. It implies that we need to now get summation y squared and summation x y. Let us start from x y. So for you to get summation x y, you have 50 times 72. That's x y. 50 times 72 will give you what?
3,600.
3,600. 3,600. So that means that 3,600. 38 times 49 will give you what?
1,862.
1,862. 71 times 69.
4899.
4899. 66 times 68.
4488.
4488. Then let us sum it because we are talking about summation xy. So summation xy, we imply that we have 3,600 plus 1,862 plus 4,899 plus 4,488. I repeat, 3,600 plus 1,862 plus 4,899 plus 4,488.
14,849.
14,849. So 14,849 is our what? Summation xy. We are getting there. We only need summation y squared to complete our unknown for us to get our b. Why am I saying this? Our n is the number. Is the what? What is the n? We have n1 and what? n2. We have n1 and what? So our n is what? Our n is 4. So if our n is 4, it then means that you don't need to solve for n. Just because we already know the value of n. So let us continue. Our y squared. If our y is 50, y squared will be 50 times 50. That's 2,500. 38 squared is what? 1,144. 71 squared will give you what?
5,041.
5,041. 66 square will give you what? 4,356. And this one, when we sum it together, 2,500 plus 1,454 plus 5,051 and plus 4,356. It will give us what? It will give us 13,341. So our summation y squared is 13,341. Now, from all this information that we have, it then implies that we only need to substitute into the formula to get our b. Am I communicating? So if you are not careful while you are trying to solve it, especially when you are doing the summation, one thing about statistics is this: the moment you get it wrong from that aspect, every further effort will be wrong. So if I were you, I would be meticulous about all this summation y, summation x, and so on and so forth, because they are the bedrock upon which all other will lies. And it's always stepwise. By the time you get the value of your summation y and summation x, it then implies that if you input them, you will get the appropriate answer. You get the appropriate what?
Answer.
So when we say our n is 10, our n is 4, let us now say b is what? By formula, n summation x y minus summation x summation y all over n summation s summation y square open bracket summation y square. into bracket. What's our summation xy? 14,849. What's our summation x?
225.
225. What's our summation y? 258. Get that right. Our x still remains 4. Summation y squared is 13,341. Am I making sense? What's our summation y?
225.
225 squared. I hope you are getting it.
Yes.
So, moving forward, we now have 4 times 6. 4 times 14,849. 4 times 14,849.
59,396.
59,396 minus, we are trying to clear the bracket. 225 times 258. 225.
So there's another one.
Alright.
Summation S is 258.
Summation S is 258.
Y summation Y is 225.
Summation y is 225. There's no problem. So let us continue. So then implies that our summation y is 258 and our summation s is 258 and our summation y is 225. Just get that in place.
That's 58,050.
58,000 and 50. This is our numerator. So let us go to denominator. Are you getting the point? So for denominator, our s still remains 4. 4 times 13,341.
53,364.
53,364. 225 squared. Sorry, our y is 225. Yes, 225 squared is what?
50,625.
50,625.
625.
So, merely looking at what we have here, you will know that you are right. Because by the time you subtract the numerator, you get a single value. You subtract the denominator, you get a single value. And from there, you get the coefficient that you are experiencing. And what that coefficient is the slope or the gradient. Is the what?
The slope of the gradient.
59,396 minus 58,050.
1,346.
1,346. 53,000, that's the numerator. We are done with that. 53,364 minus 50,625 will give you what?
2,739.
739. From here you get an equation, a coefficient. Usually it can be greater than 1, it can be less than 1, depending on the magnitude of the slope. You know it's a slope. So we cannot say it has a range, we cannot say. But you should know that you will get a coefficient. Sometimes it can be 0 point something, sometimes it can be 30 point, 10 point, it depends on the result. So 1,346 divided by 2,739 will give us 0.49. So that means our B is 0.49. Chicken that. For us to now say our B is 0.49, easily we will get our A. Why? We have already taken our time to find solution Y. We have already taken our time to find solution X. We will now get our B. Like I said earlier, for us to get our A and B, we will have to work with Y and X. If you did not work with Y and X, you cannot get A and B. So if our B is 0.49, then our A will be what? What's our solution Y?
225. Can we approximate that?
Do not approximate when you are not done. Because it will also approximate or affect further results. At the final answer, you can approximate and you let us know the significance or level at which you are approximating so that it will be clear. But if you are still working, do not approximate. Am I making sense? You can only stop at 4 figures. Assuming it is 0.4914 now, you will leave it like that so that you work at 4 figures. So even if you want to approximate at 4 figures. Am I making sense? So let us continue. Thank you for that wonderful question. So A will now be summation y is what? 225 minus 0.49. What's our summation x? 258 all over. What's our n? 4. Our n is 4. So a equals to 225 0.49 times 258 will give us what? 0.49 times 258.
126.42.
126.42 divided by 4. So let us say 225 minus 126.42 will give us what? 225
98.58.
is here what?
98.58.
98.58 divided by 4. Now, I want to say this. It is important for us to note that our n is 4 for both y and s. Somebody will now ask, is there a situation whereby y and s will have different n? If they are different, it then means that you cannot regress an uneven numbers. Or let me say you cannot regress because you are trying to see whether A affects the other. That means one of them does not have a dependent variable or independent variable as the case may be. That is why if our n is 4 for one of the variables, it will be 4 for the others because it's pari passu. It cannot be one will be more and one will be what? One will be less. So I am saying this because it is part of those things that we have to take note of when we are trying to find our unknown, or let me say when we are trying to solve for unknown. More importantly, our A is now 98.58 divided by what? Divided by 4. 98.58 divided by, and that will give us what?
4.645.
Our A is 24.645. I will not say we will approximate. I will not be tempted because we can still use it to predict. Are you getting my point? But if the question does not allow you, ask you to predict, the question is just saying what is the regression model or regression equation. You can approximate here. It will be glaring that you are approximating. But if you are still going to use it for prediction, just leave it like this so that your prediction will be a little bit accurate. Am I making sense? Ordinarily, for every regression equation, there is plus e, usually silent. We assume that e is error and is 0. So if we assume that the e is error and is 0, we are not considering estimation of error. So don't bring another error into the equation by approximating when you still need to predict with the model. That is another caveat. But here we are only going to formulate the model, so we can approximate, and that will be what? A equals to 24.7. So if A equals to 24.7, going forward or moving forward, our what? Our model now will be y equals to A plus B, B what? Bs. Then our y will be equal to what our A? 24.7. What our B? 0.49x. Regression model. Equation 2. Unlike equation 1 that we have here. From this equation 2, you can use it to predict. How? If somebody scores 50 in, get me right. If somebody scores 50 in mathematics, you can be able to tell us the score that person for their mathematics. Let us see whether we are right. Go back to that question. What's the first student score? In mathematics? 72. 0.49 times 72. Somebody should do that. 0.49 times 72.
35.28.
35.28 plus 24.7.
59.9.
59.9. What is the score of that person? further mass? 50. So that's the estimation that person can score 59.98. If that person score what? 72 in. So look at it, almost plus error components, almost predicting what that person might score. That's why we say this equation can be used for further prediction. It will give you an estimate of what that person will likely score if the person scored this. You can see that 59 point something is almost close to what? 50 at least. When I say almost close, it means that plus error, plus or minus, it will start give you something around, because it's an estimate. Thank you for listening.